Professor Bialis here. In this video we're going to be talking about section 5.6 where we cover dividing polynomials. Okay? Now there are two main methods that we're going to be covering in this section and a third method in section 7, but the two fundamental methods we are talking about here will be dependent upon what type of divisor we have. Okay? Your divisor is going to be the thing that you're dividing by. So if I say 3 divided by 4, our 4 is the divisor, the 3 is what we call the dividend. Okay, so let's start by talking about a polynomial divided by a monomial. Okay, let's go right into some examples, but I want to give you a little bit of an idea of why we're doing what we're doing. So let's say we have that. So what this is a binomial divided by a monomial. What I want you to start with whenever we're dividing by a single term is to change this into a fractional form. Remember, fractions mean divide. So what we have is 25x cubed plus 5x squared over 5x squared. Okay? A lot of people want to just cancel this out and call it a day. The problem is this is dividing here, but it's also dividing here. Okay? So what we're going to do is what I like to call the breakup method. Whenever we have multiple terms on top and a single term on the denominator, all I do is write it separately like so. That's it. Okay? Now, what that turns into are two problems like we saw in that 5155 combo lesson. Okay? So, 25 divided by 5 is just a 5. 3 versus 2, 2 are gone, 1's left. 5 divided by 5, x squared divided by x squared, that all goes away. So what we're left with is, in this first term, just a regular old 5x. And remember, whenever something cancels out, it cancels out to a 1. So what we get is a 1. And there you have it. Now, why are we allowed to break it up? I just said you break it up. Why? What we're doing here is the opposite of this. Let's say we have 3 over 7 plus 2 over 7. How would we add those two fractions? I would take those numerators and add them up like so. And that's where we get the 5/7. But look at what we did. We took these two fractions, pulled it to 1. What's stopping us from going the other way? That's exactly what we're doing in this division method. We're taking this and we're separating it into two fractions. That's why we took this broken into 2. Okay, so polynomial divided by monomial, breakup method. Again, it's not really a technical term, but that's what we're doing. We're just breaking it up into multiple terms. Let's look at a couple more examples. See, we have that. Okay, now again, we have 3 terms divided by a single term, divided by a monomial. So what we're going to do is we are going to break this up into 3 separate fractions. Just like that. Okay, notice the denominator doesn't change, it just gets copied under each term of the numerator. And then we just reduce each of those 3 parts. So 30 divided by 5 is 6. 7 versus 2. 2 will lose. 5 will be left. 10 divided by 5 is 2. X squared and x squared, all of that goes away. The 5's here cancel, but be careful. 1x loses, 1x is left. So this term, all we have left is that 6x to the 5th. This term, all we have left is a nice clean 2. And then this last term, be careful, we're not left with x. Where is the x? The x is in the denominator, we need to show that. So what we're going to write is 1 over x. And there we have it. Okay? And that's all there is to it. You break it up, you simplify them, you move on. Let's look at one more like this. So, we have 3 terms divided by, again, a single term. The number of terms on top doesn't really matter at all. It's the number of terms on the bottom that's really key. So, again, in this case, we're going to make 3 separate fractions. And we have that. Especially in this case, a lot of people want to put a 3 here, x here, y here. That denominator never breaks up. Okay, you copy the denominator as many times as you need. And then we reduce. Okay, so 12 divided by 3 is 4. 1x loses, 2 x's are left. 1y loses, 2 y's are left. 18 divided by 3 is 6. X is gone, y is gone. 6 divided by 3 is a 2. Y's are gone. Now, what I like to do is I like to, if it starts to get a little too complicated, too many things going on, take the numerator, then the denominator down. So in this case, I have a numerator of 4x squared y squared. Denominator's empty. If you need to put that 1, do it. I don't want you to always do it. I want you to kind of break that habit if you can. But if right now you need it, put it there. Okay? But again, long run, erase it. And if that means you write it and then erase it right away, go for it. Okay? Just do what works for you. Then minus. The only thing left here is 6 on the top, nothing on the bottom. So again, just a 6. But then this last term, what's in the numerator? There's a 2. What's in the denominator? X. And there we go. Okay? So that is your breakup method, and you use that when you are dividing by a monomial. Now what happens when we're dividing by something other than a monomial? Let's see how that works. Let's say we have a polynomial divided by a binomial. Okay, now technically what we're about to do can be used when we're dividing by a trinomial, 4-term, 5-term, all that. We're going to be focusing on binomials though, because as you'll see later on in like college algebra and pre-calc, that's typically what we're going to be dividing by, are those binomials. Okay, now what we are going to be using for this is long division. Okay, now this is the exact same long division we learned back in 3rd grade. However, you may not have been doing it since 3rd grade. So let's remind ourselves of the process of long division, and then we're going to apply it to polynomials. So let's say we have 1,632 divided by 5. Okay, again, just pay attention to the process right now. So long division would be set up with the divisor going into our dividend, like so. And then what we did was we tried to figure out how many times 5 went into each of these digits. So 5 goes into 5 goes into 16 3 times. Okay? Doesn't have to go in exactly, but go in as many times as you can without going over. So 5 goes into 16 3 times. Then we multiplied, 3 times 5 is 15. We subtract. 16 minus 15 is 1. Then we carry down that 3. That's one cycle. Then we just keep doing it again and again as long as we need. Okay? 5 goes into 13 now, twice. 2 times 5 is 10, and I subtract. 13 minus 10 is 3. Carry down the 2. Do it again. 5 goes into 32, 6 times. 6 times 5 is 30. I subtract, I get a 2. Okay, now there's nothing else to carry down, so I'm technically done. There's a few things that we can do with this leftover piece right here. We could put R2, the remainder of 2, but we can do a little bit better than that. Sometimes we would put a decimal and continue the problem, but we can't really put a decimal in a polynomial. So when we get into the polynomial, what we're going to be doing is taking this and putting it over our divisor. Again, that 5 is where we get that. Okay, so we get 326 and 2/5. That's all there is to it. Okay, so we pick how many times we need to multiply. We then multiply, subtract, carry down. Do it again. Pick how many times we multiply, subtract, carry down. Pick how many times we multiply, subtract, carry down. That's all there is to it. Okay, let's now see a polynomial version of this. Let's see how that works out. Okay. I wrote it as a fraction on purpose because I don't want you to look at that and say, oh, just break it up. Because remember, we're not dividing by a monomial. If there was a monomial on the bottom, break the thing up. Then you're done. But that doesn't work here because if we did that, it would be like this. And honestly, there's nothing we can do with that. We break it up and we're stuck. And to me, this is more complicated to look at than this. Okay, so when we have 2 terms in that denominator, we need to think of long division. Okay, so again, there's nothing we can do with this because these x's can't reduce because this is an x plus 5. So this is useless. If we do the long division, I have x plus 5 as my divisor, and I have x squared plus 12x plus 35. Now, here's the thing. When we pick the values that go on top, what we multiply by, we are only looking at one term at a time, and we're looking at the first terms only. The rest of it's going to be in play, but we're not making anything happen with those. We are focusing on the first terms. So what I want to happen is this x term here to match that x squared term there. Okay, the rest of it's going to work itself out. So what do I multiply x by to make it an x squared? I need to multiply by another x. Okay, now what do I do with that? I multiply. But when we multiply polynomials, what do? We distribute. So I'm then going to distribute this x over that divisor. So I get x squared plus 5x. Okay, that was the multiplying part. Now I subtract, but remember when we subtract polynomials, we typically distributed the negative. Okay, so what I'm going to do here is change all the signs. That's distributing a negative. But don't think of subtract or distribute. Think of change the signs. Change the signs, that tells you exactly what you need to do. And then x squared minus x squared. That's gone. Why did we want them to match? So that they would go away. Okay, now I get 12 minus 5x is 7x. And then I carry down that 35. Okay, that's one cycle. So let's recap. I thought, what do I multiply this first term by to make it that first term? Just like here, what did I multiply 5 by to make it a 16? Here I got kind of close. Here I want it to be exactly the same. Okay? Then I multiply. I multiply the 3. Here I multiply the x. But in this case I distribute. After I distribute, I change the signs. Change the signs. This first term should always cancel out. If it doesn't, something's wrong. 12 minus 5 is 7. Carry that down. And then I repeat the process. So let's do it again. Now I want this x to match the 7x. What do I multiply x by to make it a 7x? A 7. Then I distribute. 7 times x is 7x. 7 times 5 is 35. What do I do then? I change the signs. After I change the signs, 7x minus 7x is gone. 35 minus 35 is also gone. I got nothing left. So there's no remainder. This divided evenly, and my answer is x plus 7. If you ever want to check this, what you would do is you would multiply these two things right here. Distribute them, FOIL them if you want to call it that. And then you should get this dividend underneath. Okay? So again, if that means you have to watch this video 3 times to follow through that process, please do so. This isn't something you just glance at and boom, I got it. Okay? You really have to internalize that process. But don't overthink it. Okay? All you're doing is making those first terms match. You distribute, change the signs, carry it down, do it again. Okay? Let's look at a few more examples of this. So again, we see that it's a division problem. We have to decide, are we doing the breakup method or long division? It's not always going to be given to you. Okay, so always decide that first. In this case, since there's 2 terms, we have to use long division. So I'm going to take 2x minus 1 going into 6x squared plus 7x minus 7. If you feel like you've got that process down, pause this video, give this a shot. Okay? But if you want to just watch and see how this plays out, please feel free to do that as well. Okay, so I want first terms to match. 2x needs to be a 6x squared. 2 times 3 will give me the 6. X times x will give me the x squared. Now I distribute that 3x. 3x times 2x is 6x squared. 3x times negative 1 is negative 3x. Now watch me here. Change, change. Change the signs. That move right there makes it kind of hard to look back through your work and check it. Okay? Always remember that those signs were changed along the way. So if you're checking through this at the end, do that distribution and make sure the signs are opposite of what they were from the distribution. 6x squared minus 6x squared is all gone. That should happen every time. If it doesn't, don't just cross it out and say that's what's supposed to happen. Make sure it actually subtracts out. And then 7 plus 3 is 10x. Carry down minus 7. Now I do it again. What's a 2x, or what do I multiply 2x by to make it 10x? 2 times positive 5 gives me the 10, and I already have the x. So now I distribute a 5. 5 times 2x is 10x. 5 times negative 1 is negative 5. Change, change. Gone. Negative 7 plus 5 is negative 2. Okay, now there's nothing else to carry on. Also, the degree of this is 0. The degree of this is 1. When the degree here is less than the degree of this, you're done. Okay, the degree is talked about in section 2 when we introduced polynomials. Okay, but when the degree here is less than this, you're done. That means this is our remainder. Now, how do we write the remainder? We would put a plus, then that remainder over the divisor. And this whole thing is your answer. Another way we could have written this is with a minus right here. And notice how I kind of shifted the minus out in front. That's perfectly fine. But then if this is positive, make sure you put the plus sign. I see a lot of people miss the plus sign when it's positive and they leave it like that. That's wrong because that's understood to be multiplication. Okay, so that's why it's important. I always like to just put the plus sign there and I put the negative on top there. That way you're never going to risk not putting the plus sign if you always put it down. And there's your answer. Nothing more to it than that. Okay? So let's look at a few more examples. There's a couple things about this example that I really want you to pay attention to. Okay? First of all, do you notice how this is not in descending order? The whole point of this process is so that we chip away term by term along that polynomial. We need to have it in descending order in order to do that. So the first thing I'm going to tell you on this, always write these in descending order. Okay? If you're taking notes, write that down. Always write these in descending order. So I would write this like so. Okay? Now there's one other thing that's going to pop up. I want to kind of stumble onto it so you can see the issue that we have. Okay? So we wrote it in descending order. It's long division because we had the two terms here. Now, let's go through the process. I want 3x squared to be 3x to be a 9x cubed. So 3 times 3 is a 9, and I need x squared to make that x cubed. I then distribute that. So I get 9x cubed plus 6x squared. Now, what I would then do is change the signs, and then I would add down the columns. Now, maybe you noticed already. Do you see how these terms are not like terms? I can't combine those. So here's something that we should do right off the bat, but it's easy to forget, so I wanted you to see what you're going to run into. Again, the issue is these are not like terms. Because if you look at the original dividend, what were we given? We were given x cubed, no x squared, then x, then the constant. We have a missing term in there. So this is what I'm going to do. And I should do this right away once you notice it. In your dividend, if you're missing a term, fill it in. That way you have a slot for every single term and power you can hit along the way. Okay, so we had an x cubed, put the x squared term there, then x to the first, then nothing. Notice I put a 0x squared because 0 times anything is 0. I didn't add any value, I just put a spot for all the x squared terms. Okay, notice if you start the problem and you forgot to do it in the beginning, you can always add it in later. But it's better if you do it right away. Okay, after that, same old stuff, we're sailing explaining through the problem. So we did the 3x squared, we multiplied, we changed the signs. Those cancel. 0 minus 6 is negative 6x squared minus x plus 5. Now I do it again. What do I want a 3x to be? I want it to be a negative 6x squared. So 3 times negative 2 gives me the negative 6. I have an x, I need another x. Okay? And then I distribute. So I have negative 6x squared minus 4x. Okay? A lot of people, they want to put a positive 2 because they're like, well, I want it to cancel out, so I'm going to get a positive 6. Remember, I still have to change the signs. Now they're opposite signs. Okay? Then, negative 6 plus 6 goes away. Negative 1 plus 4 is 3x plus 5. Okay? Let's continue. Degree here is 1, degree here is 1. We're not done yet. 3x times what gives you 3x? A 1. I distribute that 1 and I get 3x plus 2. What do? Change the sign. Gone, because 3 minus 3 is 0. 5 minus 2 is 3. And then to finally finish it off, this degree is less than this. I just say 3 over 3x plus 2. Now I want to be very clear on something because we're going to dig a little deeper into this the next section. Our remainder is 3. That's it. How we place our remainder in our polynomial is this fraction. But if I said, what's your remainder? It's just the 3. Okay? And this whole thing is your answer. Okay? Let's look at a couple more. Okay. Now, first of all, identify breakup versus long division. It's long division because we have this binomial. Okay. Now, in the previous example, I said to first write them in descending order, which they are, and then always fill in those missing powers of x. That only applies to the dividend. Notice we have x squared and then we jump down to that constant. You don't need to put in a 0x when we have this in the divisor. Okay? Now, let me write it out and I'll explain why. Okay? The reason why I put the 0 here is so that I had a place to work. This is where all my work is going to be found. I'm not going to do any work down here. Okay, so it's not necessary to put that 0x in there. Again, it's just a tool to help us stay organized. I don't need to be organized here. It's over here that I need to be organized. Okay, so let's go through this. X squared needs to be a 2x to the 4th. So I need to multiply by a 2, and then I need to multiply by an x squared to get the x to the 4th. Now, watch how I distribute. 2x squared times x squared is 2x to the 4th. 2x squared times 3 is 6x squared. Do you see how I jumped over here to keep the like terms together? Just stay organized. Then I switch the signs. Let me use a different color so you can see it. And if that helps you, use a different color. Okay, that's not going to hurt anything. Now, 2 minus 2, those are all gone. Just because I jumped over here doesn't mean that this no longer exists. This is still here. Negative 3x cubed, then there's nothing, carries down the negative 3x cubed. Plus 1 minus 6 is negative 5x squared. And then we carry down that next term. Now here's the thing. When we have a lot of terms, it's not going to hurt anything to carry down all of it. Okay, that way if you need it, it's there. So again, as these problems get a little longer, I would just carry down everything that follows. Okay, do those calculations and then carry down all that other stuff. Now, same process, I need this to be this. So I'm going to go negative 3x. I'm going to distribute. So I have a negative 3x cubed, then a minus 9x. And don't be afraid. If you just write down minus 9x and you're, oh, that doesn't work. Just erase it. That's why it's important, use pencil. Okay, because if you make a mistake, I can erase it real quick and then be done with it. When you get into chapter 6, there's going to be a process called guess and check, where there's going to be a lot of erasing. And that's just part of it. That's just part of the process. So again, make sure you're using a pencil when you're doing your work. Then I change the signs. Let me use that. Like so. Again, I'm not saying make it negative. I mean change the sign. Those cancel. I get negative 5x squared coming down plus 4x plus 6. Okay, now the x squared needs to be a negative 5x squared. So I'm going to multiply by a negative 5. I distribute the negative 5. Negative 5x squared minus 15. Change the sign, change the sign. Negative 5 plus 5 cancels. 4x comes down, and then plus 21. Now notice the degree here is 2, the degree here is 1. I'm done. The degree down here is less. So there's my remainder. My remainder is that entire expression, 4x plus 21, and then I put it over x squared plus 3. Again, if someone says, what is your remainder? My remainder is 4x plus 21. When I put it in the polynomial, it's this whole fraction here. And this is my quotient for the division. Okay? Let's look at one more. This one I really suggest pause the video, try that on your own, okay? Now, when we're doing this, this is a deceiving problem because it looks like, oh, I'm just going to reduce the x's, cross out the ones. But remember, we cannot cross out those terms. We got to divide the whole thing. And since this is a binomial, that tells us to use long division. So I'm going to go with x minus 1 going into, now how do I write this? Remember, I have an x cubed, but then I need to compensate for that missing x squared and that missing x. And then I bring back that constant. Okay? That gives me a spot for any power of x that I can encounter. So, let's now see how this plays out. I need an x to be an x cubed. So x times what gives me that? X squared. And then distribute. So I've got x cubed minus x squared. Change the sign. Those then go away. Okay, and again, guys, every single one of these, they cancel, they cancel, they cancel. Because we make them match, and then we change the sign, making them opposites. So, nothing plus x squared is x squared. And then I carry down at least the next term, but again, it's not a bad idea to carry the whole thing down. Okay, then it's there if you need it. Then I need an x to be an x squared, so I'm going to multiply by x. Distribute the x. X squared minus x. Change, change. That's gone. 0 plus x is just x minus 1. What do I multiply x by to make it an x? Just a 1. It already is an x. Distribute the 1. 1 times x is x. 1 times negative 1 is negative 1. Change, change. And a beautiful thing happens. All of it goes away. So our remainder is 0. Okay, it divided evenly. I don't need to throw 0 over anything. I just leave it. And there's my answer. Okay? So again, the purpose of this section, we're dividing polynomials. If you divide by a monomial, I don't care how many terms are on top. If there's one term on the bottom, just break it up. Okay, and then simplify each fraction. If there's 2 terms on the bottom, that's when we go into that long division. Okay, again, long division could be applied when we're dividing with 3 or 4 terms, but we're going to primarily be sticking with just 2 terms as that divisor. Okay, so take your time with this. This is a very orderly thing. It's the same couple steps. You just pick the right thing to make it multiply and match. You distribute, subtract, or change the sign, bring it down, move on and do it again. That's it. Nothing more to it than that. Okay? So, as always, keep working hard. Let me know if you have any questions, and I'll see you next time.